Okay, Mr. McKee here once again, and today I'm going to walk you through how to convert from grams of a compound to moles of a compound or vice versa. So we are working through the examples on page 33. If you want to follow along with me, I'm going to go through examples 1 and 2. So these are the steps that we're going to be following right here. And rather than talk about them now, I'm just going to work through them with you in the examples. So our first example problem says to find the number of moles in 50 grams of carbon tetrachloride. So this would be very simple if we could look at the periodic table and see the mass of 1 mole of carbon tetrachloride, but we can't because the periodic table has only elements on it. It does not have compounds like this. But what we can do is add up the masses of the individual elements within the compound. So I'm going to show you how to do that here. So I've given you these tables to break stuff apart. So in carbon tetrachloride, we have 1 atom of carbon, which has a mass of 12.011 grams. And we have 4 atoms of chlorine, each of which has a mass of 35.45 grams. So since I've got 1 carbon, I multiply 12.011 times 1, and of course I get 12.011 grams. And I have 4 atoms of chlorine, so I multiply each chlorine by the mass of chlorine, which is 35.45, and I get this number right here, which is 141.8 grams. All right. So to get the mass of 1 carbon tetrachloride molecule now, I'm going to simply add those masses together. When I do that, the number that I get in the calculator is, I'll write it off to the side here, 153.811 grams. So remember our rules for significant figures when we're adding. We're going to round our answer to the number of decimal places as the least precise part of the problem. So 141.8 only goes to the 10th place. So we're going to round our answer to the 10th place, which means we're going to round this number right here. And as always, when we're rounding a number, we look at the next digit over, which in this case is less than 5. So we're going to round down to 153.8 grams. So we just figured out that 1 mole of carbon tetrachloride has a mass of 153.8 grams. From this point forward, everything we're going to do is identical to what we learned last unit. We're going to use our mole map here, and we can convert from moles of carbon tetrachloride to either particles, if we want, or 2 grams, which is what we're trying to do in this particular problem. And we figured out that the molar mass of carbon tetrachloride, again, is 153.8 grams. So that's going to be our conversion factor that we're going to use. So let's plug things into our train tracks. Again, this is going to look like everything else we've done with train tracks this year. So our starting number in unit from the problem, again, was 50.0 grams. Notice that we've got 3 significant figures there in that number. Our ending unit, we're trying to figure out how many moles that is. So the conversion factor is the relationship between these two things, grams of carbon tetrachloride and moles. And that relationship we just figured out is 1 mole of carbon tetrachloride is equal to 153.8 grams. So that's going to be the conversion factor that I plug into the train tracks down here. As always, I put my starting number in unit here. I arrange my conversion factor so that the thing I'm trying to cancel is on the bottom. So note that I've got grams on the bottom here, and then I've got grams on top. And because grams appears on both top and bottom, I'm able to cancel them out, which is the whole objective. And that gives me an answer that is in moles of carbon tetrachloride, which is the result. So I plug everything into the calculator. times on top and divide down. So I take 50.0 grams and multiply it by 1, which of course is going to be 50 grams. And then I divide by 153.8 grams. And here is my calculator answer. I get 0.325097529. And of course, I need to round that. And since my starting number in unit right here had 3 significant figures, I'm going to round my answer to 3 significant figures. So I'm going to round this 5 right here. I look at the next digit over, and it tells me to round the 5 down. And I get 0.325 moles of carbon tetrachloride. So 50 grams of carbon tetrafluoride is equal to 0.325 moles, is what we just figured out. So why don't you guys pause the video and do the U-try. Okay, welcome back. Let's go over the U-try together. In this particular question, it says to calculate the moles of 150 grams of H2O2. H2O2 is also known as hydrogen peroxide. So you've been given 150 grams of H2O2, and you're trying to figure out how many moles that is in this particular problem. So let's break hydrogen peroxide into its components. We've got hydrogen, and we have 2 of them, and we have oxygen, and we have 2 of them. Very similar to the formula for water here, just a little bit different. So the mass of hydrogen is 1.008, and the mass of oxygen is 15.999 grams. Both of those are in grams. So if we multiply 1.008 times 2, we get 2.016 grams. And if we multiply 15.999 times 2, we get 31.998 grams. Now in this case, both of these numbers have 3 decimal places, so we probably won't need to worry about rounding the answer, but let's confirm that here. 31.998 plus 2.016 is equal to 34.014 grams. So we just figured out that 1 mole of H2O2, hydrogen peroxide, has a mass of 34.014 grams. Now we're going to use that as our conversion factor to solve the problem down here. So the problem is calculate the moles in 150 grams of H2O2. So 150 grams, and it's 150.0 grams of H2O2 is going to be our starting number and unit, and our ending unit is going to be moles. So we are starting with grams, 150 to be precise, and we are going to figure out how many moles that is going to be. And my conversion factor is going to be 1 mole is equal to 34.014 grams. So let's plug that all in here. My starting number in unit is going to go where it always goes, 150.0 grams. And I'm going to multiply by my conversion factor right here, and I'm going to put grams on the bottom, 34.014 grams. I don't need to write H2O2 every time since we know what we're working with here. There's no other elements involved, no other compounds involved. That's equal to 1 mole. Putting grams on the bottom in my conversion factor enables me to cancel it out because it appears on both the top and the bottom. And now I need to divide 150 by 34.014. And I get the following in my calculator. Let me scroll down. Okay, when I look at my starting number in unit, I see that it's got 4 significant figures using my Atlantic Pacific rules that we learned about earlier in the year. So I need to round the 4th digit over here up. So I look at the 9, the next digit over is greater than 4, and so that tells me to round it up. So this is going to become 4.410 grams. And that is my answer. So I just figured out that 150 grams of H2O2 is equal to 4.410 moles, actually, not grams. Sorry about that. As always, reach out to me if you have any questions, and have a great day, folks.